Hello and welcome to the video, How Many Solutions? In this video, we will be looking at how to solve linear equations algebraically, and we will be including examples of linear equations with one variable, with one solution, infinitely many solutions, or no solutions. So what do I mean by this? So far, you've been learning about equations and everything has had one answer. For example, x plus 2 equals 3. There's only one number I can add to 2 to get a positive 3, and that's a positive 1. We've looked at more complex answers, but so far everything has only had one answer. However, this is not always true. Some equations can give us two answers. For example, when we work with exponents, we have x squared equals 9. This means x times x equals 9. And we know that 3 times 3 equals 9, so x has to equal 3. But we've done some study into integers, and we also know that two negatives make a positive. So negative 3 times negative 3 also equals 9. So x could be negative 3. So when we work with positive exponents or exponents that are even, we end up with two possible answers, positive or the negative version of the number. So let's dig a little bit deeper into our definitions for one, many, and no solution. So one solution is an equation where only one number can make a true statement. For example, x plus 1 equals 2. The only answer for x is 1. Only 1 plus 1 gives us a positive 2. Infinitely many solutions is an equation where any number will make a true statement. And no solution is an equation where no number will make a true statement. So let's look at our very basic examples of these. So we have the first one is one solution, x equals 3. There's only one number we can think of that equals 3, and that's 3. 3 equals 3. This is our true statement. So in one solution, it will work down to where only one number will make it true. In infinitely many solutions, many different numbers could make this statement true. So let's say x equaled negative 5. So negative 5 we replace with the first x, and negative 5 we replace with the second x. And it is true that negative 5 equals negative 5. We could do 0.4 for x. And 0.4 does equal 0.4. This is a true statement. We could do negative 1,002 for x. And on the other side, we would substitute in negative 1,002. These are all true statements. Okay. And our no solution puts us in a situation where nothing ever works for x. So let's say x equals 2. So you have 2 equals 2 plus 1. Okay, so 2 equals 2 plus 1 is 3. 2 does not equal 3. And when we have an equal sign with a bar through it, it means not equal. This is not equal. And there's no number I could ever think of that would make this true, because the number with the plus 1 will always end up slightly larger. So let's look at some examples, and we're going to look at what clues we can find to help us know if it's one, many, or no solution faster. So first we'd like to solve. I like to drop in a line between my equals, under my equal sign, to keep the two halves of my equation apart. And as you know from previous videos, we move all the variables to the same side. And we do that by using the opposite. So if we have a positive 2, we'll use a negative 2. And we have to keep everything that we're adding under the bars the same. Okay, so 2x minus 2x is 0x. That leaves us with the negative 3. 4x minus 2x is 2x plus 6. we're going to move the 6 by using its opposite. What I do to one side, I have to do to the other. Positive 6 and negative 6 make a 0. So 2x equals, so this is subtraction, so I'm going to change it to plus and negative. So negative 3 plus negative 9, negative 6 is negative 9, jumped ahead into my answer. Divide by 2, that's how we undo multiplication. X equals negative 4 and 1/2. And we could write that in decimal form as well, but I'm going to leave it. So we can see x worked out to have one solution. Let's look at our next one. We're going to move the 3x to the opposite side. The opposite of a positive 3x is a negative 3x minus 3x. So 3x minus 3x leaves us with 0. So we just have our plus 4, so a positive 4. 3x minus 3x leaves us with 0. That leaves us with a positive 4. And 4 does equal 4. That's a true statement. So this line's a bit long. I'm going to erase it and draw a shorter one. And then our final example. We're going to start by moving this 2x to the opposite side. 2x minus 2x is 0. I'm left with a negative 5. 2x minus 2x is 0. I'm left with a positive 3. And positive 3 does not equal a negative 5. So we're done working that one. So let's talk about what these last two mean. So when you end up with a true statement with no variables, because they've canceled each other out, this is what we call mini solutions. Any number I use for x will work down to something equals the same thing. So if I used 1 for x, 1 times 3 is 3, 3 plus 4 is 7. Same thing on the other side, 1 times 3 is 3, 3 plus 4 is 7, and 7 does equal 7. If at any point you're working and you end up with a not equals or a false statement, this was a no solution problem. So let's look at what we get, what hints we can be given. So with one solution, we have different coefficients for the variable. Okay, and we can see that here, one coefficient is a 4, the other coefficient is a 2. Okay, so we have different coefficients for our variable. For many solutions, we have the same coefficient for the variable, and the same constant. Okay, so we can see we have the same variable. They're both 3x. And we have the same constant, plus 4 and plus 4. Okay, and our no solution, we can see that we have the same coefficient for the variable, but we have different constants. Okay, so we have the same coefficient, they're both 2x, but this is a plus 3 and this is a negative 5. And that will always lead us to making a false statement. Okay, so let's look at a few more examples. So before we can do anything, we have to deal with the distributive property in this first example. 2x plus 8 equals 2 parentheses x plus 4. So we distribute first, and we're left with 2x plus 8 on one side of the equal sign. And we have 2x, and 2 times 4 is 8, okay? I have the same coefficient with the variable, same constant, so this is many solutions. Okay, the same thing I have to do here. I have to distribute before I can solve. So I'm going to distribute the 4 to the x and the 4 to the negative 1. I know in front of my x there's an understood 1. 4 times 1 is 4x. 4 times negative 1 is negative 4. Equals 1/2 times x, and we'll do 1/2 times 8. I know there's an understood 1 there. 1/2 times 1x is 1/2 x. 1/2 times negative 8, half of 8 is 4, so that's a negative 4. So even though my constants are the same, it doesn't matter. My coefficients on my variables are different, so this will give us one solution. Last example, okay? We don't have any distributive property, but we do need to combine some like terms. So 5x and a negative 2x, so 5x minus 2x is 3x. Bring down my plus 2 equals 3x plus 6. Okay, I have the same coefficients, but different variable, different constants. So this is no solution. And that's how you find out if an equation has one, infinitely many, or no solutions. Thank you for stopping by.